All right, so now we're going to be adding and subtracting rational expressions or fraction expressions. So one thing to remember, when we need to add or subtract fractions, we need a common denominator. So here we could use 6 as the least common denominator, right? We can put them both over 6, but to get to 6, we would have to multiply this by 3 top and bottom. So 3/6 is equivalent to 1/2. And we'd have to multiply this by 2 to get to our common denominator of 6. So we get 4/6. And then we get to keep our denominator of 6 and add the numerators, 3 plus 4, or 7. 7/6, or 1 1/6. Okay, so keep in mind we have to do those extra steps when we're trying to add or subtract with fractions. We're going to be doing that same idea, but with expressions today. So to add or subtract fractions, we need to find the least common denominator between all fractions. Create equivalent fractions, which is what we did when we created 3/6 and 4/6, by multiplying the top and bottom by any missing factors. So you might notice that 6 has factors of 2 and 3. This had a 2 and was missing the factor of 3. This had a 3 and was missing the factor of 2. So that's what we're alluding to here. Multiply top and bottom by any or all missing factors. That helps us create those equivalent fractions. Then we get to add or subtract the numerators, like we added 3 plus 4 to get to 7, and keep the common denominator. Okay, so we're going to be doing that idea. Here's one with just fractions again. So what could I use as a common denominator? Well, as we look at these two, for sure, they're going to meet at 150. If you multiply them together, that guarantees a common denominator. So 150 could be a common denominator, but is that the least common denominator? Definitely not. We'd get some bigger expressions which require a lot of factoring and simplifying in the end. We want to avoid that. So instead, what we can do is look at the factors of the denominator. Well, 10 is 2 times 5, and 15 is 3 times 5. And what we can do is look at what do they already have in common. Well, they already have a 5 in common. So let's include that in our LCD. Let's include 1 5. So our common denominator is going to need 1 5, but we can't get rid of any of these factors. So we're going to need a 2 and a 3 to also be a part of our least common denominator. So if you multiply those all back together, we get 30. The first place multiples of 10 and 15 would meet is 30. Now you could probably figure that out without breaking this down and looking at what they already have in common, listing those commonalities once, and then things that are not common like the 2 and 3 and also including them. However, when we're doing this with expressions, it's not going to be necessarily as obvious. So yeah, so if we were going to actually go ahead and add and simplify these, we'd want to put them both over 30. Right, there's our common denominator, and then figure out what we need to multiply each to get there. Well, this had a 2 and 5. It has the 2 and the 5. So what factor was 10 missing? It's missing the 3. So we would multiply the top and bottom by 3. It's give me 9/30, my equivalent fraction. Well, this had 3 and 5. What factor was it missing? It's missing 2. So we would need to multiply the top and bottom by 2 to get 14/30. And now that we have common denominators, we get to keep the denominator and add the numerators. 9 plus 14 is 23. 23/30 would be our simplified fraction. Okay, so let's up the stakes a little bit and let's talk about this with expressions. Now, if I look at these denominators, we've got 3 times x, 3 is prime. 6 is not prime though, so I'm going to go ahead and break that down into its prime factors. Whoops, 2 and 3. And x squared we can even think of as a x times x. Okay, so these would be all the prime factors. So to find our least common denominator, the first thing we're going to look for is what do they already have in common. So I say they each already have a 3 in common. So let's include 1 3. They also already have an x in common. So let's include 1x. So I'm just circling them to make them stand out here. Now, what are things that weren't common to both fractions? This 2 was not common to both fractions. But again, remember we can't get rid of it, so I need to include it in my least common denominator. And this extra x was not common to both, but again, I can't get rid of it. The only case where we could get rid of it is maybe if the individual starting fractions were simplifiable, but they were not in this case. So what is my LCD? If I multiply this all back together, 3 times 2 is 6, and x times x is x squared. 6x squared is the first place we can make them meet. Now, you might have been able to look at these and go, hey, if I multiply this by a 2 and an x, we've got common denominators. And that, in fact, that's exactly what we'll need to do. So let's give them both their common denominator we desire, 6x squared. And of course, our second fraction already has the common denominator, so we don't need to change the numerator at all. But in this one, what factor or factors were we missing? It's missing the 2, and it's missing the x. So we need to multiply top and bottom by 2x. So that would give me up top 8x. And now, once again, now that we have our common denominator, we get to keep the denominator, 6x squared, and add the numerator together. Now in this case, those are not like terms, so we can't actually add them together, but we can write it as one fraction, 8x plus 5 all over our common denominator, 6x squared. Now, if we were thinking about the denominator here, we would need to state an exclusion, something like x cannot equal 0, right, for this factor. Okay, so let's try another one. What is the LCD of this? So there's some directions up here. I'm not going to read through them because we've already talked about them. To find the least common denominator, we can list out our factors. So 21 is 3 times 7, and then we've got 3 x's. 12, if you did a factor tree for that, is 2 times 2 times 3, right? 4 times 3. And then we've got 5 x's, x to the 5th. So if we're looking for what is our least common denominator, what do they already have in common? Well, I see they have a 3, so let's include a 3 in there. And they also have several x's. In fact, we can even kind of group them. They each have at least 3 x's. So let's write those x's. You could do them each individually or do them in a group like I'm doing here. Now, what do they have that's not common? Well, there's a 7. Can't get rid of that. There's these 2 2's. Can't get rid of those. And then there's these 2 spare x's, which I also can't get rid of. So we have a lot of stuff to multiply back together, but we are finding the least common denominator, even though it's going to be rather large. So 3 times 7 times 2 times 2 is 84. Makes sense? That's times 4, and that's times, that's times 4, and that's times 7. So 84x to the 5th is our least common denominator. So if we were making our equivalent fractions, we'd put them both over 84x to the 5th. Pretty big, ugly denominator, but that is the least common one, which would give us less simplifying in the end if possible. So what would I need to multiply by? Well, notice this one was missing 2 2's and 2 x's. So let's multiply it by the missing 2's. 2 times 2 is 4. And the missing 2 x's, x squared. So we're multiplying the whole top and bottom by 4x squared. So the top gives me 16x squared. Now what is my second denominator missing that the first one had? And the only thing that wasn't common is that 7. So all we need to do is multiply top and bottom by 7. And now we have our common denominator that we can keep. And we can add the numerators together. All over 84x to the 5th. So normally we try to see if this factors. This does not factor. So there's no other simplifying we can do. And of course, if we were going to state something about the domain, we would say the denominator x cannot equal 0 from that x to the 5th term. Okay, here's another one, a little more complicated as far as the expressions they've given us. So let's go ahead and factor the denominators. So if I take out a 2 from this first one, we're left with x plus 2. And our second one is a factorable quadratic, x minus 4 times x plus 2. So what do these already have in common, if anything? And keep in mind, if they have nothing in common, then your least common denominator is just all of the factors together. Remember, we can't get rid of any of them. But in this case, we do have a couple that already match. We've got x plus 2's whole expression. X plus 2 needs to be part of my LCD. And things that are not common, like our x minus 4, right? Not common, can't get rid of it. And this extra 2, which we can't get rid of. So I'm going to go ahead and throw that in the front there. So my least common denominator, it needs to have a 2, an x plus 2, and an x minus 4. So this is what I want as the common denominator for each of these two fractions we want to combine. So it's guaranteed to be a common denominator and the smallest possible one so that we don't have to do a bunch of factoring and simplifying in the end if it's unnecessary. So this one already had the 2 in the x plus 2. What factor was it missing? X minus 4. So we need to multiply the top and bottom by x minus 4. Okay, I'm going to skip writing in the bottom just because it makes a mess. But up top here, we do go ahead and distribute to get x squared minus 4x. And the reason we're going to do that is because when we add these numerators, we want to be able to combine like terms. So we'll go ahead and multiply the numerators out when we can. All right, our second one, it's got x minus 4 and x plus 2. It's got 2 of them. The only thing it's missing is this 2. So we're going to multiply the top and bottom by 2. And that gives me 30 up top. So now we can keep our common denominator, 2 times x plus 2 times x minus 4, oops, plus 2 times x minus 4. And up top, we've got this quadratic x squared minus 4x plus 30. Are there factors of 30 that add up to 4? No, I don't think so. So I don't think we can factor the top, which means I don't think we can simplify this. So there is our final answer. It doesn't simplify. And if we were writing the domain, of course, the denominator x cannot equal -2 or +4. Okay, now when you're subtracting, you need to be more careful. And I find that this definitely helps. Change it to adding the opposite. Now here's where you need to be careful. We are going to add the opposite of the entire second numerator. Now note in this case, there's just a 4 there, but if there's an expression, you need to distribute that negative sign to everything in the top. Okay, so now we really have 2/5 plus -4 over 15x. So of course we'd want to find a common denominator. Hopefully we'd see that we can get these to match at 15x. It's a common denominator between each. Right, we would just need to multiply this first fraction by a 3 and an x, top and bottom. So up top, that would give us 6x. And our second numerator, we wouldn't need to change at all. So we end up with 6x minus 4 over the common denominator, 15x. Now we can factor a 2 out of the top. We should always try to see if we can factor, and maybe every once in a blue moon, we can simplify further. In this case, the 2 and 15 do not have a common factor, so we can't go any further. But there we go. There's our added together single fraction and as simplified as we can make it. And of course, again, if we were stating something about the domain x cannot equal 0. Okay, let's try another example. So this time, again, we have subtraction. Add the opposite. Do this to help yourself out. Add the opposite. Now it is the opposite of everything in the second fraction's numerator. So we're going to go ahead and distribute that. Now this becomes plus -x plus 1, right? Distributing our negative sign here all over x plus 2. Okay, now we can go ahead and factor our denominators. We got a difference of squares here, x plus 2x minus 2. And our second one does not factor at all, but I can think of it as the expression x plus 2. So what do these already have in common? They've already got an x plus 2. In fact, this one just needs an x minus 2, and they'd match. So let's go ahead and multiply the top and bottom by x minus 2. Okay, so now we would have a common denominator. Here we are going to need to FOIL or distribute through. So negative x times x is negative x squared. I'm going to go ahead and write my 6 over here as well. So it's from the 6 here. So we have negative x squared. Negative 1x times negative 2 is positive 2x. 1 times x is 1x. And 1 times negative 2 is negative 2. This is all over our common denominator, x plus 2x minus 2. So let's go ahead and combine some of this mess up here. We've got a negative x squared. 2x and 1x makes 3x. 6 and negative 2 makes 4. Now, maybe that quadratic up top factors, but I certainly don't want a negative 1 in front of it. So what I would probably try to do is factor out a negative 1 to make that positive x squared minus 3x minus 4, just to see if that quadratic factors. Are there factors of 4 that subtract to 3? Ooh, 4 and 1. I think that is factorable. So we're going to keep that negative 1 out there. And this is x minus 4 and x plus 1. So it does factor out. However, are we able to cancel with any common factors in the denominator? No. So a little bit in vain, but good practice there to check and see if maybe we could factor that. Maybe it would simplify further for us. It did not simplify further, but that's fine. We can say the domain here is that x could be any real number as long as it does not equal negative 2 or positive 2. Okay, so again, we're looking at the least common denominator. Okay, so this is also a pretty tough part for this lesson. It's called complex fractions. And look at this mess. We've got two fractions being added together, divided by two other fractions being added together. Now there's different ways to approach this. You could find a common denominator for the ones up top, make it a single fraction, so some number over a number, or expression over expression. You could simplify the bottom into one fraction by finding a common denominator, and have a number over a number, and then you have a fraction divided by a fraction, and you would multiply by the reciprocal. That's one approach. The other approach, which is what we're going to do here, is to multiply through by the common denominator of all fractions. Which is going to be a little bit simpler here. So here's what I mean by that. We're going to, first of all, if everything is not a fraction, make it a fraction. And they are. Everything's a fraction. So we're going to look at all of our denominators. We got 4 of them. What would be the least common denominator between all of them? Well, some of them have a 2 in there, so we just need 1, 2. I don't think we need an excess number of 2's. But we're going to have a 3. We're going to have a 5. And we're going to have that extra x. Can't get rid of any of those. So if we multiply this all back together, this is 30x. That is the least common denominator for everything. Okay, so here's what we're going to do. We're going to multiply through, meaning we're going to put parentheses here. We're going to multiply by 30x over 1 in the top. And then we're going to do the same thing in the bottom. Multiply by 30x over 1. So multiply through by this common denominator. So we're going to think about distributing it to this fraction. So hopefully we would see the 30 and the 3 are going to reduce to a 10. And then we would have x times x, x squared. We're going to have 10x squared. Okay, and the denominator is just gone. We don't have to worry about the denominator, which is nice. Okay, here we're going to distribute the 30x here and simplify this. 30 over 2 will be 15, and we'll have our x left over, so positive 15x. Okay, over, and now we're going to distribute 30x through in the bottom. 30 over 2 would reduce to 15, and in fact our x's would even cancel out, so we just end up with 15. And distributing through here, 30 and 5 would reduce to a 6. 3 times 6, this would give me 18x, I believe, up top here. Okay, so now we've gotten through, we've just got one fraction left. Maybe we have some stuff we can factor out of here. Like in the top, I see we can take a 5 and an x out, which leaves me with 2x plus 3. And In the bottom, I'd see we can take maybe a 3 out. I'd probably write the 18x first. So let's take that 3 out. And that would leave me with 6x plus 5. So are there any common factors or anything we can reduce? No, unfortunately. So here's what we get. There's our final answer. And if we're talking about the domain, let's see, the only place x really occurs in the denominator is there. X cannot equal 0 from the original. So as long as x is not equal to 0, we should be okay. I guess we should probably also exclude negative 5/6. But don't worry, I don't think I make you go through and do the whole domain on problems like these. They're already tough enough. So let's try another one, because that could be a little bit confusing. So in this one, we're going to, again, let's make these fractions. If everything's not a fraction, just make it one. And let's find the least common denominator for all fractions. So maybe I'll do that a little further over this time. So we have 2, 1, 1, and x. So I guess the ones we didn't need to list twice, but it's just a 1. So I think 2x is going to be our common denominator. So we're going to multiply through the top and bottom by 2x over 1. So let's go ahead and do that. You multiply through here, the 2's are going to cancel. We're just going to be left with x squared. Now here, keep in mind we do have a minus sign, so we're going to think of that as plus negative 5. So this is a negative 5 we're dealing with. Now nothing will cancel out, but we are going to end up with negative 10x. So this is what we get in the top of our fraction. Okay, in the bottom, we'll distribute our 2x through. This gives me 12x over 1, or 12x. And distributing through here, we can see that the x's would cancel, and we just end up with plus 6. So here's our fraction. Is there anything we can factor out? I see we can take an x out of the top. We could take maybe a 2, or actually, sorry, a 6 out of the bottom, which leaves me with 2x plus 1. Are there any common factors to cancel out? Again, it looks like the answer is no, but we'll go ahead and leave it in that factored form, just so anybody that's reading it knows we did factor it out, and that it just doesn't reduce any further. So we would exclude, let's see, x can't equal 0. And from our final answer here, it looks like x cannot also equal negative 1/2. You don't really need to worry too much about the domain on these problems. We'll really just be looking for the simplified expression. So again, the easiest way to deal with complex fractions, find the least common denominator of everything, and then distribute it through and just simplify as you go. The denominators all disappear. When you do that, you're just left with kind of one big fraction that you want to try to factor and maybe reduce if you can. Okay, that's it. We'll do some more examples in class. Thank you.